Okay, so we are given the sector area. As soon as we see a sector, we are thinking part over whole equals part over whole. Of course, on the degree side, that's going to be 58 over 360. On the area side, 36.07. Is that the part or the whole? That's the part. It's the sector. It's not the whole circle. So that's the part. Because it is the part, it goes in top. 36.07. The whole, we don't know it. I'm going to call it A for area. Capital A for me means it's the big area. Small a means small area. Let's see. Time to reduce is fraction. Fraction reduces to this. Now it's time to cross multiply. 29 times a and 180 times 36.07. That gives us this. Now it's time to divide both sides by 29. So that gives me this. Are we done? No. This A reminds us this is the area of the whole circle. We want the diameter, just the diameter. So what do? Well, I remember that area is pi r squared. That's the formula for area. And oh look, I have the area now of the whole circle. So if I want to find the radius, I can take this area and substitute it into the formula right here. That gives me this. Now it's time to divide both sides by pi. Dividing by pi, now I have 71.26 equals r squared. What do you think I'm going to do now? That's right, I'm going to take the square root of both sides to unsquare that r. That gives me that the radius is 8.44. Am I done? No. We're supposed to find the diameter. This is just the radius. What do I do to get the diameter? Well, hopefully you said double it. Multiply by 2. So that's going to give us 16.88 centimeters for the diameter. And that is the answer. Okay, we need to find the shaded area, the area of the sector. But be careful, the one thing you have to watch out for, 109 degrees is the wrong angle. We need the angle in the shaded area, not the white area. So what am I going to do? Hopefully you said let's subtract 360 minus 109. If I do that, I get 251. That's the angle we're going to use when we set this up. So here we go. Part over whole equals part over whole. That's what we're going to do. So that leaves us with 251 degrees over 360 equals x over 25 pi. Where did the 25 pi come from, you ask? Well, let me show you. We have the radius. The area of the whole circle is pi r squared. That's pi times 5 squared. 5 squared is 25, so that makes 25 pi. Part over whole. 25 pi is the area of the whole circle. I don't think this will reduce. So we are stuck with the big numbers. So it's time to go ahead and cross multiply. 360 times x equals 25 pi times 251. That gives us this. Now it's time to divide by 360 on both sides. So this would be the exact answer, 1255 pi over 72. Or I could write this as a decimal. That would be 54.76 meters. Okay. Number 3. When you have a shape inside of a shape like this, you should set up a diagram showing your strategy. So we will take the outer shape and subtract the inner shape. So our plan is to do what minus what? Hopefully you said we're going to do the area of the circle minus the area of the square. Okay, circle minus square. So let's set that up. First of all, the area of the circle. That's pi r squared. Well, the radius is 6. So that's going to make 36 pi. That's the area of the circle. Now, the area of the square is going to take a little bit more work. To calculate the area of the square, there are lots of ways to do it. One way is to think about the hypotenuse of this right triangle. Okay, so I've got this right triangle doing this. The hypotenuse is 12. If you remember, when you have a special triangle, a 45-45 right triangle, in the hypotenuse position, it's always leg radical 2. In other words, if this is x, we have x, this should be x radical 2. Don't believe me? Look at the sign above the board and see what's in the hypotenuse position. I believe you will see that it is x radical 2. Therefore, x radical 2 should equal this 12. So what am I going to do? Well, I need to divide by radical 2. So I'm going to divide by radical 2 on both sides. Okay, if I do that, this is what I get. I get 6 radical 2. Okay, that tells me that both of these x's are 6 radical 2. Well, now I can find the area of the square, because the area of a square is length times width, or base times height. Well, the base and the height are both 6 radical 2 like we just found. So that means I'm going to be doing 6 radical 2 times 6 radical 2. And that turns out to be 72. So, from the beginning we said we were going to take the area of the circle and subtract the area of the square. So that means we're doing 36 pi minus 72. In fact, that would be the exact answer. It doesn't get any more simplified than that. 36 pi minus 72. But of course, you can also write this as a decimal. would be 41.10 square feet. Okay, that's how we do number 3. Alright, looking at number 4. This is similar to what we were just doing on the previous slide. We have a shape within a shape. We have a big circle and inside a smaller circle. So when we subtract, we're going to just simply do the larger circle minus the smaller circle. So let's see, the larger circle. Well, we know that the area of a circle is pi r squared. In both cases, obviously. Alright, so all we need to know is the radius in both cases. Well, let's go and do the small circle first because that's the easiest. In the case of the small circle, what is the radius of the small circle? Is it 14? No, of course it's not 14. The radius of the small circle is 7. Half of the diameter. So that means over here I'm going to have pi times 7 squared, which you could probably just skip straight to 49 pi. Okay, so that's the area of the small circle. Now, back to the area of the large circle. I got to be careful. The radius of the large circle, everybody. Tell me what the radius of the large circle is before I get there. Now here's a hint. First of all, the radius of the large circle is not 5. Please, for goodness sake, do not look at this 5 and think, oh, that's the radius of the large circle. 5 is not a radius. It only spans the shaded area. It does not reach all the way to the center, as a good radius should. Now this red and blue that I've drawn over here, now that's a radius. That's the radius of a big circle. It goes from the center all the way out to the edge. So of course, what is the length of the radius of the big circle? That's 12. Okay, so the radius of the big circle is 12. That makes this pi times 12 squared, which is 144 pi. And as we said, we're just going to subtract these two. Now this would not be the exact answer because these can actually be subtracted. They are like terms. If you do the subtraction, you get 95 pi. So that will be the exact answer. Or, of course, you can write it as a decimal if I ask for a decimal. 298.45 meters. Okay, let's take a look at number 5. As soon as I see that I'm dealing with a sector, right away I'm thinking part over whole equals part over whole. So let's get it going. This time we have the degrees, so let's start off with that. That's the easy part. 40 over 360, of course. I need part over whole. I've got this. Is this 100.88? Is that the partial area or the whole area? Does it go in the top or the bottom? Well, it's the area of the sector. The sector is not the whole circle. It's the part of the circle. So it will go in the top. In the bottom, I'm just going to put A. Capital A, representing the area of the whole circle. I like to use a lowercase a to represent the area of the sector, but that's just me. Time to reduce the fraction and cross multiply. The fraction reduces to 1/9. If I cross multiply, well, look at that. A times 1, that's just A. And then I'm just going to do 9 times 100.88, and that's going to give me 907.92. So that would be the answer to number 5. We found the area of the whole circle, capital A, and that's exactly what we were supposed to find, the area of the whole circle. Okay, one more problem. Again, we have this shaded area. We're supposed to find the area of the sector. So again, as soon as I see that it's a sector, I'm thinking part over whole equals part over whole. I've got the degrees, so let's go. 30 over 360. Let's see, over here, I'm looking for the shaded area. I'm looking for the part. I don't know it, so I'll put X. Or if I wanted to, since it is a sector area, I could use a lowercase a. It doesn't matter. But for the whole is the area of the entire circle. So I need to do pi r squared. Radius is 9, so r squared is 81. So that makes this 81 pi. Time to reduce the fraction and cross multiply. Alright, so first of all, 30 over 360 reduces to 1/12. Cross multiplying, I'm going to have 12 times x, and then 81 pi times 1, of course, is just 81 pi. Alright, last step, of course, is to divide both sides by 12. This reduces to 27 pi over 4 inches. So, that is the partial area, so that is the exact answer to this question. Or, as always, we could write this as a decimal. So that's going to be 21.21. Okay, that's how we do number 6.